Hello and welcome back to 5-Minute Chemistry. Today we are going to be talking about the concept of valence and how it is related to the different atoms. So in compounds we already observed it, and it is part of Dalton's atomic theory that compounds are made up of atoms of different elements, and the ratio of the atoms of these different elements can be described in some kind of a simple fraction with whole numbers. And what we observe, if we take a look at the different types of compounds, that these ratios are not really random. In a lot of cases, they strictly depend on what kind of elements are found in these compounds. So, for example, if we look at the compounds that are containing hydrogen, we can see compounds like hydrogen chloride, hydrogen fluoride, which have one hydrogen atom and one chlorine atom, or one hydrogen atom and one fluorine atom. So the atoms are in a 1-to-1 ratio. In water, we have two hydrogen atoms for one oxygen. In hydrogen sulfide, we can have two hydrogens for one sulfur atom. Here we have three hydrogens for a single nitrogen and three hydrogens for a single phosphorus. Or in methane, we can have four hydrogen atoms for a single carbon atom. What we never find is that one hydrogen atom bonding to multiple atoms of a different element. If we take a look at sodium and potassium, we find something really similar. Sodium and potassium will both bond to chlorine in a 1-to-1 atomic ratio, and to oxygen they will have two metal atoms to every one oxygen atom in their oxides. If we take a look at calcium, which is another metal, so calcium chloride will actually have 1-to-2 ratio of chlorine. So compared to potassium and sodium, the ratio of chlorine went up by 2. And if we take a look at the oxides, so here the ratio of oxygen also went up by 2. And if we move to aluminium, here we find that to every one aluminium atom there will be 3 chlorine atoms, or we have this very complicated oxide here. So based on these observations, we can find that the atoms of certain elements like to have a fixed number of bonds. So if we take a look at water, in this case, in water, the oxygen atom wants to make 2 bonds, so it will bond to 2 hydrogens, while the hydrogens will want to make only 1 bond, so both of these hydrogens will just bond to this central oxygen atom. In hydrogen chloride, both the hydrogen and the chlorine only wants to make 1 bond, so they just bond with each other. So we can, based on this, say that hydrogen and chlorine has the valence of 1, so they are monovalent, while oxygen has the valence of 2. If we take a look at ammonia, in ammonia the nitrogen has a valence of 3, and therefore will bond to 3 hydrogen atoms. For methane, we can say that carbon here has a valence of 4, it is tetravalent, so you can see each hydrogen bonds with 1 carbon atom, and the carbon atom itself bonds with 4 hydrogen atoms. Calcium with chlorine, so chlorine is monovalent, so you can see that each chlorine will make 1 bond to the calcium, and calcium is bivalent, or has a valence of 2, so it will bond to 2 chlorine atoms, while in the calcium oxide case, both calcium and oxygen wants to make 2 bonds, and we can just draw it like this. They just make 2 bonds between the 2 of them. And we can explain carbon dioxide with this method, for example. So carbon wants to make 4 bonds, oxygen wants to make 2 bonds. So each oxygen makes 2 bonds with the 1 carbon atom in the middle, and this way the carbon atom can make 4 bonds. In the case of aluminium oxide, this is how I could draw it for you. So all the oxygen atoms can make 2 bonds, and all the aluminium atoms can make 3 bonds in this case. We can also use this model to explain the oxygen molecule, which we find in oxygen gas, and we just say that the oxygen atoms want to make 2 bonds with each other, and for nitrogen, because nitrogen wants to make 3 bonds to form a molecule. So based on this theory of valence of atoms, we can predict the molecules that are present in certain compounds. So if we think about hydrogen peroxide, so in hydrogen peroxide, if you just measure atomic ratio, you will find that it has 1-to-1 ratio of hydrogen and oxygen. So if you would want to write down an empirical formula, so empirical formula is the formula which only contains the ratio of atoms. So we just write down the symbols here. We could write it like H1O1 if we wanted to, but we don't put the 1 in the index over there. So this is the empirical formula of hydrogen peroxide, but what we found is that oxygen actually wants to make 2 bonds. But here it only bonds to 1 hydrogen, so maybe we can predict, based on that oxygen generally has a valence of 2, that here actually hydrogen will bond to the oxygen, and the oxygen will also bond to another oxygen, and the molecule will actually be H2O2, and this will be the molecular formula of hydrogen peroxide. So now, because it is 2, we write down the actual number of atoms in the molecule in the index. So in the empirical formula, we would write down the numbers of the ratios of the atoms, and in the molecular formula, we write down the number of actual atoms in the molecule. And so similar thing we can do with hydrazine, which has an empirical formula of NH2. So here, for every 1 nitrogen atom, we will have 2 hydrogen atoms as a ratio in this compound, while writing down the molecular formula. So because nitrogen wants to bond with 3 other atoms, so 1 nitrogen atom will bond with 2 hydrogens and will bond with another nitrogen atom. So the molecular formula we can predict would be N2H4, 2 nitrogen atoms and 4 hydrogen atoms. And we can test this. So using Avogadro's law, you could make a hydrogen peroxide gas or hydrazine gas and measure the volume and the mass of the gas, and you could check whether the particles that exist in the gas, do they really correspond to the molecule that you would predict from this theory of the valence of the atoms. And this is how science works. So you have a theory, you make a prediction based on your theory for something that you don't have a real experimental results for yet. And once you made the prediction, you do the experiment and check whether your experiment proves or disproves your theory. Okay, so this is for today, and I will see you tomorrow. Bye bye.